So I'm Emma. I'll be here as a technical support during the tutorial. And I want to introduce our speaker, Tvrtko, our tutor, Tvrtko Sternak. And he's a software engineer at Air Technologies, and he will hold the simplifying event-driven services with FastStream, a how-to-guide tutorial. So enjoy.
Okay. So let me just share my screen, then we can start. Okay. So as you heard, my name is Tvrtko, and today I'll be talking to you about FastStream. It's a open source library we developed in January to help us and in the future, hopefully, other developers to be able to quickly develop async services in Python. So let's just first let's just start with the introductory presentation. Oh, it seems that let's try. Sorry. Let's see. Oh. So yeah, okay. So yeah, our motivation was we had a customer that we had to develop a churn prediction model, and after we developed the model, we had to somehow deliver our model's predictions to our customer. So the first step was to use Fast API and wrap the model inside the REST API. So every time a customer wants some prediction, he will query the get endpoint with the data of his clients, and we will return a prediction of whether that customer will churn or not. This approach worked in the beginning well for us. So using Fast API, we were able to quickly develop and dish out a service on which the customer can connect and get some predictions, and everything worked fine. But the issue was that they in the future didn't want to use REST API. They wanted to transfer their message routing from REST API to async API, mainly Kafka. So we had to develop something that looked similarly to Fast API. So as you saw in the Fast API, you have everything handled. The data that is coming in is parsed for you automatically. Yeah, I think some question. Thanks.
Sorry for interrupting. Can I please ask you to send the link for the materials in the chat?
So the materials were, I think, shared over the email with Emilia. So
yeah, I know, but if you can just send it here.
I'm not sure
Because
where.
I can share it with everyone.
Okay, but I'm not sure where materials.
Just make sure
I have the link.
to share it with everyone and not only with the hosts and the panelists.
Okay, I mean I can share it via email afterwards, but yeah, at the moment I'm not sure where the materials I've sent.
Okay.
Okay, so let's proceed. So The idea was to develop something similar to FastAPI. So in the case of FastAPI, you just decorate your function that needs to gather the input data. It's a model that parses the JSON into the input data, and then you just decorate your function with the get app.get decorator, and everything will be handled for you automatically. So you don't have to think about any of the routing, any of the parsing. Everything is like delivered for you automatically, and you just write your Pythonic functions that handle those data. We wanted something similar. So when we wanted to connect to a KafkaBroker, we wanted to like write our own function that will parse the input data, do some predictions, and then return those predictions in the prediction JSON model. So the async communication isn't like just one endpoint. So we want to decorate our function so that we signal that we are publishing to the predictions topic. And also we want to decorate it to subscribe or in Kafka lingo, consume from the input data topic. So in this case, this design will call your on input data function each time there is a new message on the input data topic. And when we predict something and return a prediction, this publisher decorator will take that prediction return value, and behind the curtains, it will produce it to the prediction topic. So this is something that we decided we need. We need something that will be easy to write, something that is testable, and also a big bonus point would be to have some automatic documentation generation, and for it, of course, to be well maintained. And then we scoured the web and Git, and surprise, surprise, we didn't cover anything. So we decided to write it ourselves. For the message parsing, we decided to use Pydantic. So it's a standard library that is used for defining the models of JSON. And when we input those JSON, it will be parsed and put into Python classes. For the backend, so for the communication with Kafka, we decided to use AO Kafka. It's an open source library on Git. Written in Python. It's an async way of communicating with Kafka topics. And for the documentation generation, we decided to align with the async API. It's a movement that people want to have some tidy documentation written in a similar way that the REST API documentation is written. In the meantime, while we were developing our library for connecting to Kafka, there was a person in Russia that was developing the quite similar or the same library that was used to connect to Rabbit message queue. So he decided to use Pydantic for parsing of the JSON input messages. For his backend, he decided to use Pika. And for documentation generation, he decided to use async API. So our first step was to develop FastKafka. And when we contacted that person in Russia, we decided to connect our two libraries and make something that will abstract the async communication and allow the users to easily reformat their code. So if there's a need for connecting to Kafka one day and the other day you want to like reformat your application to be able to connect to Pika, you can easily do it with like 2 or 3 lines of code changes. So yeah, we decided to connect FastKafka, do some abstractions with Propan, and thus FastStream was born. So how did we design it and how does it work? So the consuming, you define your function that is on input data, and it will consume messages of format input data. And to connect it to a Kafka topic, you just decorate it with broker.subscriber. Before that, you need to, of course, instantiate your broker. So you go to FastStream Kafka and define your KafkaBroker. And in this case, we are connecting to localhost and wrap your broker into a FastStream application. Everything else is handled for you automatically. So you don't need to worry about some special cases, how to connect to Kafka or anything like that. You just write your Python function, decorate it, and it will be called every time there's a new message on input data. So for producing, there are two cases. So first one is you define your function, and when you process your data, you return the value you want to produce into your Kafka topic. And then you just decorate your function with the broker.publisher. So each time this function is called, the return value from this function will be also published to the prediction topic on Kafka. If you, for any case, want to use that publishing logic on multiple places, or you don't want to decorate your functions, or you're not sure if you will if you want to have some ifs, if there's some cases where you want to produce a message or not, you can always instantiate your publisher in like an object way. So here we create a prediction publisher from our broker, and then we when we want to publish some message, we just await the prediction publisher to publish. One interesting thing about this is we had some cases where people wanted to start their broker programmatically, not through the CLI. So we added an async context manager functionality inside our broker. So if you want to just run your script and start your broker, send some message, close it, you can always like start with async with broker, do your publishing logic, and then you're done. So after that, we were mainly handling JSON formats, but we had some requests about Avro formats and some other message formats that could happen inside of Kafka. So we decided to add a custom encoding and decoding logic for our application. So you can always define your custom decoder, which will receive a Kafka message. You can decode it inside this function and then return it. And then to override the usual decoding logic for your application, you just pass it inside your subscriber decorator. So after that, one of the main functionalities of Kafka is it has multiple partitions of one topic. That's how they ensure that it's quick and messages can be processed in parallel. But what if you are sure that you want to, what if you want to ensure that messages of one type, or let's say one customer, are always consumed by the same application? That's the case where you use keys. So when you use a key, the Kafka broker will hash that key and decide which partition you will be subscribed to, and this will be like constant. So when you subscribe, your consumer will always consume from one partition. That's how you ensure that you're consuming like for one customer and customer. So how it's done, it's like quite simple. So when you're publishing or when you're consuming, you just define the key under which you want to subscribe to the partition. So next thing was people want to publish multiple messages at once to Kafka, or let's say consume. This ensures that if you know that you can consume multiple messages and do something with them in parallel, you don't need to go through them one by one, but you can always like describe when you instantiate your decorator, you can always define batch true. And in this way, your handle function will not get message by message, but it will consume a list of messages that come in batch, and then you can do with them whatever you would like. It's the same logic with publishing in batches. So if you would like to publish multiple messages, you just call your publish function of your publisher and pass in a list of all the messages. Next thing was, so the security. In AI Kafka, the instantiation of the producers and consumers was done quite messy. So these are all the parameters that you need to define when you're creating your AI Kafka producer. And if you would want to define some security mechanism like SSL or using some usernames or passwords, there are like a lot of things that you need to take care of. And the area for making a mistake is quite big, we know, because we spent a couple of days of like trying to define simple username and password to connect to our secured Kafka broker. So we decided to abstract that. And inside the FastStream, you have like broker security, and you can import the security object that you want to use when connecting to a Kafka broker. So from something like this and like trying to figure out what you need to set to connect to the secured Kafka broker, you get something like this. So you know you want to connect with the SASL Scram 256, and then you like create your Scram object, pass in the SSL context, username and password, and when you're creating your Kafka broker that connects to the remote Kafka, you just pass in the security object. If you would like to use any of the other securities, so you just instantiate another object, create SSL plaintext, and pass in to your broker. So the next step was the testing part. So at first, in the first iterations, we always had to test our brokers. Are they consuming and producing messages correctly? Was by connecting them to a real instance of Kafka. This is like really slow, and you want your tests not to be dependent of whether your broker is running or not. So we decided to create a test Kafka broker context manager, which when you pass your broker implementation inside of it, it will patch all the functions and connect your broker to an in-memory instance of Kafka. And your test will be independent of like network connection or whether the broker is up or not. So you can quickly test your logic without the need for some external resource. So how is it done? First, you prepare your broker for testing by wrapping it in a test Kafka broker. Then you create a subscription for the prediction topic. So we know our application will produce something to the prediction topic. And then so first we send some input data to our broker, and then we check if it has consumed it. So on input data. And the logic of our broker, it needs to produce some prediction from the input data. So we can check and assert that our on prediction function was called with the correct prediction. So if there's a case that you want to be really sure that everything is working fine, you can always override this patching with the in-memory broker by setting the with real boolean to true. So in this case, we will not redirect your FastStream application to something in memory, but we will let it connect to a real broker and communicate over it. So yeah, from like the first slides, the idea was to connect to Kafka or to RabbitBroker. And so you can see here, we are creating a Kafka broker that is encoding and decoding messages. And if we would like to connect instead to a RabbitBroker, the change is one line. So you change from Kafka broker to RabbitBroker, and everything else will be working just fine. And yeah, so to wrap it all up, you need to pass your broker into a FastStream object. This object takes care of all the startup, shutdown, parallelization, and documentation logic for you. So you define your processing logic using the broker, and then you pass it into the FastStream object. And to serve it, you just need to, you go to your CLI and you run the FastStream run and pass the module and then the object of that module that is the FastStream application. If you would like to run like multiple consumers in parallel, which is quite a big case in Kafka, you can always define the number of processes that you want to run. So in this case, with workers equals 2, the FastStream will run two brokers for you to consume the messages in parallel, and it will take care of all the setup and the teardown of both of those workers. And the last thing was when we develop our application, we want to generate some documentation of that application. So to generate the documentation, it's quite similar to the FastStream run. So you just run the FastStream docs generate application app, and then you will get a JSON file that contains the async API documentation for your application. If you would like to instead serve it as a web server, you can always like do the FastStream docs serve and pass in your application. How does it look? So in our first case, so we have we subscribe to the input data, and it will accept, like in this case, we have an example with the dataset iris. So it will accept a payload with sepal length, sepal width, petal length, petal width. Those are all booleans. At the bottom, you see an JSON example of the message that your application will consume. And after that, we are publishing two predictions. So in this case, we want to publish a string that represents the predicted species of the flower that is coming in to our application. So you can see we are publishing two predictions, and you can see the description and formal representation of the data that we are publishing. And last, you want to have a title for the documentation of your application, to author, and of course the servers that you're connecting to consume and produce the messages from. Yeah, and that's it for the introduction. And right now, let's go through the creation of the an example application. So we have created, let's go to Git, and we have created a, 1 second, 1 second, 1 second. Okay. So we have just we have a template which allows you to create the application skeleton quite quickly. So we'll create a new repository, and let's call it Data Science Conference app. Okay. And now in this template, we generate an initial application and some initial tests for your application. We also have some scripts that are enabling you to quickly test your application. Also, we are creating some workflows, and we'll go right now through them one by one. So let's clone this into our Visual Studio. Okay, so I can see there's some Q&A. So before we go to the code, let's go a bit through the Q&A. So there are some questions about how many messages can a consumer get in a batch. So you can always, when you're creating your broker, put the limitations on the size of batches. So after that, usually you are not in control of the amount of messages that are consumed. The amount of messages that you can consume are like from 0 to the maximum amount that you have defined. It's just it depends on the amount of messages that is available. So we'll go through this later. Okay, so we have cloned and opened our project in Visual Studio, and let's take a look at the application from the that we have created. So as you can see, so we are importing FastStream. From the FastStream, we are importing our main class FastStream and the logger, and also we are importing KafkaBroker. After that, we define some metadata about the version of our application, our title, and the description. After that, we define the models that we will consume and produce. So in this case, we will just consume some names and produce the greetings for those names into a greetings topic. After that, we define the broker for a that will connect to a localhost 9092, and we wrap it inside the FastStream object. After that, we define our publisher that will publish to a greetings topic, and we define our onNames function that will consume from the names topic. Inside this function, we will just format the message. So we take the name, we parse it into hello, and then we log the result and produce it to the greetings topic. The last thing that this application does is after the application starts up, it will asynchronously start to publish names into the topic by random. So Anna, Pedro, Gustavo, and so on. This is just to show that the application is able to talk. So let's run it. So first, we'll create a virtual environment. And then we can activate it. Now we will install all the dependencies that are necessary to run the project. This is also defined in advance for you inside the copied project from GitHub. So we will So now that we have installed it, it's about time to talk about a bit about scripts. So the important one is the start KafkaBroker locally. So to test this application, we will start a KafkaBroker using Docker. So you can see at the moment, nothing is running on our Docker desktop. But now the script will take care of everything. So we have a KafkaBroker running locally, and now we can start our application. So FastStream run, and then app.application. So you can see here that the FastStream application has started, and it started to listen on so the functional names. Is waiting for messages, and periodically we are sending a message to the names topic. Our application is receiving it, processing it, and then producing to the greetings topic. If we would like to observe this externally, so let's see. So Kafka by itself has a tool chain that you can use to connect to your broker and consume from it, and also produce. So we can go to the Kafka 2.13, yes. Okay, and inside of it, so you can see that we have Kafka console consumer. We define a topic that we will listen to. So let's listen to a topic names. And we define a bootstrap server. So the address of the server that will connect and listen to the topic from. So in our case, this is like localhost 9000. So you can see so right now we're listening what our application is consuming. So it is consuming from the names topic, and periodically we get some names produced. If we would want to listen to what are after processing the messages, so our application is producing to the greetings topic. We can also take a look. So here we will get hello Gustavo, hello Juliana, and all the messages that our application is. So I can now cancel this, and we can go back to Git. So one of the nice things that is happening is we are defining, so we have to make a change to start up the CI, and let's do just that. So for the next step, we would like our application not to do the messages automatically, but we would want it to receive something meaningful. So we'll delete this part where it's producing messages periodically. So let's go back to our application. DSC app. So So now that we have pushed it, you should be able to see. So there is something running here as CI. There are three things. So first, from your application, we will build a Docker image, which you can then use it to publish it in a environment that you want to use your application. Next thing, we will test your application using the tests that are defined in the test folder. And we will also deploy the FastStream documentation. So one of the interesting things here that we'll show in Git is the deploy of the documentation. We just need to give it a bit of time to generate it. So let's see. Well, okay. So what has happened? Our Git CI has opened a new branch, GitHub Pages, and there it has generated static files that can be used to deploy your documentation for your application. So how can we do that? We can go to GitHub Pages and tell to deploy the pages from branch, and we select the branch that has been generated by our CI. So we can save this. And we can now go back to our application. And so to deploy our documentation, we can use our GitHub Pages website. And the CI and the GitHub will take care of everything for us. This usually takes a couple of seconds to generate, so I don't forget more. But in like a couple of seconds, we'll see it. Just refresh it. Yeah, still it needs to propagate through the internet. So let's wait a bit. Okay, while we're waiting, we can go to the tests. It seems that it's taking a bit longer than before. So in your application, you also have the test folder. So inside the test folder, we have a simple example for a simple application. So as we've seen in the presentation, so we import our application. From it we get the identic structures of greetings and the name, and we also import our broker and our onNames function that we will assert later. To be sure that we are producing to a greetings topic, we first subscribe to that topic with an empty function, because we just want to see that our function was called with proper arguments. After that, we create a PyTest test with the test on names. We wrap our broker inside the test KafkaBroker, which will then reroute it to use everything in memory. And then we publish a name example to a names topic. After that, we check that our application was called with the argument that we have published. And also we check that our onGreetings function was called with the greetings structure, hello John. This way we ensure that all the processing was done correctly. We treat our functions inside as a black box, so we just check the inputs and the outputs on the Kafka topic. To run those tests, we can simply use the PyTest command. So you can see we have one test, and one test is passing. Usually you would introduce multiple tests for your application logic, but this is a simple example. And now let's take a look at, just find it, at the application. Yeah, okay, so everything was propagated. It seems that Git is not in the mood today to serve the page. Yeah, well, it's the live demo. Okay, so one of the interesting things I would like to also talk about is we have the integration with FastAPI done out of the box. So I will modify this example, tests and the application, to show you how to connect your sync functionalities with your async functionalities. So let me just, okay. So we'll take this source and let's modify this. So what are we doing here? First, we import a FastAPI class. We are creating our FastAPI object that we will run in the future. And to connect our FastStream Kafka router to it, we create a FastAPI compatible Kafka router that will connect to a broker on localhost 9092. We define a name structure that our router will be producing. Also, we define now not anymore in decorator context, but as a object, we define our publisher that will be publishing to the names topic. And also we define some endpoints through the FastAPI. So we have a home endpoint that will just respond with hello from HTTP. And we define a name endpoint on which we can post names that we want to publish into a Kafka topic. So to run this, we first need to add the FastAPI dependency. So let's do just that. And save it. And let's install it. Okay. Now, to run this application, we no longer use the FastStream run, but this is a FastAPI application, so we'll use their classic unicorn app.app. So you can see our server is running. It seems that okay, some FastStream object is okay. Seems that something has changed. So this is the way you would define your FastAPI application and run the server. And when you would enter the when you would post something to a name endpoint, you would instead then reroute this post to publish to a Kafka topic. Let's take a look at the test. So how it would be done. So the test for this application will be done in this kind of way. So the Fast API is using quite a similar logic to reroute its API internally, not over HTTP, to wrap the application inside of a test client. So we'll do just that. And then we are subscribing to the names topic to check if when we are calling our post endpoint, we are instead getting a message with the name produced to our Kafka names topic. And then the test looks just like this. So we test on names. We wrap our broker inside of a test KafkaBroker to keep everything in memory. And then we post to our name REST endpoint with the name Tvrtko. We check that we have got a 200 response. And after that, we check on our names topic that we have as a result from posting to this client, we have got a message inside of the Kafka topic with the JSON structure name equals. So this is pretty much it for the demonstration. And now we can go through some Q&A to see if you have any questions about the FastStream. So let's go here. Yeah, so the next question is the FastStream app deployment similar like Fast API? So yeah, it's quite the same because we wanted to copy the logic of Fast API. We really liked it. Only issue was they are synchronous, we are async. So to run your application, you do not use UVcorn, but use FastStream run and then pass to your application. So the number of workers that you can run your application is usually topped by the number of CPUs that you have. So the maximum number of workers you can run effectively is equal to the number of CPUs you have. Does it support any type of stateful functions? At the moment, no, but we also had some necessities of implementing the statefulness in FastStream, and we had some requests on Git to implement it. So in the future, hopefully, we will support it. So yeah, what if the application crashes? So in our case, we wanted to be quite resilient to the crashing. So if you get some like malformed messages, the application will log the error and then like recover from it. So it will continue to consume the messages from the topic you have subscribed to. If the application crashes, like we won't the less successful message before that will be saved that it has been consumed, but any of the other messages in the topic won't be touched. So yeah, that's pretty much it. Okay, so are there any other questions or comments about the FastStream? Guess not. So yeah, I invite you to like check out the GitHub repository, and also we have put in quite a lot of time of developing the documentation for FastStream. So pretty much all the questions and everything you want to implement should be documented here. If not, open an issue, contact us on Discord, and we will be really, really delighted to help you out. Yeah, that's it from me.
Thank you, Tvrtko. This was very interesting. And thank you, everyone, for joining us.
Thank you. Bye.
Bye-bye.